Chapter 6, Conversions between Measurement Systems. At the end of this chapter, we should be able to discuss conversions and conversion factors, including the rules for using ratio and proportion in dimensional analysis, describe how to perform conversions between household, apothecary, and metric systems of measurement. We just have one keyword for this chapter, so we'll just talk about it right now, measurable amount. Quantity of medication that can be most accurately measured within the device available. And just a tech alert, when converting between two measurement systems, the answers will not be exact due to the differences between the measuring systems. Other factors include the viscosity of the medication and the size of the device used to provide the medication. The previous chapter covered conversions within the household metric and apothecary systems of measurement. The metric system is the most common and accurate. Because all three systems are used in the United States, conversions between the systems must be covered in detail. The two other units used in dosage calculations, milliequivalents and units, are rarely converted because they are unique to individual medications. If a physician writes an order using one system and the medication is labeled using another, you need to convert the dose to an approximate value to ensure that the patient receives the correct amount. Conversions between systems are approximations and may incur dosing variability. As the metric system becomes more widely accepted, the need for conversion will decrease. Although the need to calculate a dose in household measurements will remain as long as the United States continues using the household system. Household measurements are more accurate when using actual measuring spoons as opposed to flatware. However, it is more appropriate to dispense a measuring device to ensure accurate dosing in the home environment because people may use their own flatware, which varies greatly in measurements. Conversion factors are equivalent between two measurements, whether within the same system or between different systems. Each part of a conversion factor includes a value, which is a number, and a label, which is a unit of measurement. The value of a conversion factor is always 1. It is used to change one unit to another without changing the value of the original measurement. For example, 5 ml equals 1 teaspoon and it has a numerical value of 1. Table 6.1 shows common conversions, metric, apothecary, and household system of measurements. This will also be listed on that highlighted conversion sheet that I provided in the study materials. As you can see from table 6.1, the apothecary grain has a range of equivalencies. The conversion between grains and milligrams actually varies between different medications. Table 6.2 illustrates some of the more common medications that are still dosed in both grains and milligrams. Any conversion with grains is an approximation. Another approximation is that a dram is sometimes considered equivalent to a teaspoon, which is equivalent to 5 ml, when a dram is actually given a range from 4 to 5 ml in the metric system. The conversion of 20 drops per 1 ml is based on a viscosity close to that of water. Remember that the number of drops varies according to drop size and thickness of the liquid. This conversion is not used in dosing because medications dosed in drops come with a specific dropper for administration. It is mostly used for determining day supply with eye drops or ear drops for submission to insurance companies. So table 6.2 shows common medications dosed in grains and milligrams. We have codeine, nitroglycerin sublingual, Armour thyroid, phenobarbital. Those are all dosed with a conversion factor of 60 milligrams is equal to 1 grain. And then aspirin, acetaminophen, and ferrous sulfate, which is iron, is dosed at 65 milligrams per grain. Phenobarbital also comes in strengths based on 64.8 milligram per grain. So you'll also see that on the conversion sheet. If one factor is in one system, such as the metric system, and the other factor is in another system, such as the household, either ratio proportion or dimensional analysis may be used for conversion. Rules for using ratio and proportion set up the conversion ratio with the known conversion units on the left of the equation. Set up the second ratio, the proportion with the conversion units for the unknowns. Label the units so that the like unit is placed in the same position within each other. This sets the ratio so that they are equivalent to each other. Cross multiply and divide to solve for the unknown. And let's do example 6.1.
All right, so example 6.1 and 6.2 are the same problem. They just, one of them is going over it using ratio and proportion, and the other one is using dimensional analysis, which in our program we use proportions. So, in ratio and proportion. So, that's how I will do these two examples. So, we need a conversion factor between milliliters and teaspoons. So, if we go to our chart, we should see that 1 teaspoon is equal to 5 ml. Now we have 10 ml. How many teaspoons is that? So we're going to start off with our x. 5x is equal to 10 times 1, which is just 10. So we have 5x equals 10. We want to get x alone, so we need to get rid of that 5. So we're going to divide this side by 5. That makes that cross out, and we have x left. We also have to do the same thing to the other side. So 10 divided by 5 is 2. And the answer is x is 2 teaspoons.
Conversions between household and apothecary systems. The apothecary system has only a few measurements that, although not commonly used, do convert into household measurements. Of note are minims to drops, drams to teaspoon, and ounces to tablespoons. Cups, pints, quarts, and gallons are used by both systems. Length is not measured in the apothecary system. So figure 6.1 shows some equivalence between apothecary and household measurements. Although the single step conversions can be performed using ratio and proportion or dimensional analysis, the book suggests that you use DA when converting with the apothecary system to keep better track of the units. And I will say this many times during these videos, I am totally fine with whatever system you use to get the answer, but I will be doing the examples in ratio and proportion while the book does the examples in some of them dimensional analysis. You can see their examples versus how I set them up, which I think is easier to understand. So it's easier to write out the words and convert all numbers to Arabic when performing the math and then change the answer back to Roman numerals and symbols. Remember, this is a learning experience only as the apothecary symbols are prone to misinterpretation and the recommendation is to use the metric system. So you will see apothecary system a little bit out in the field. Sometimes you'll get a doctor that writes a prescription using the apothecary system, although um, the amount of doctors that are writing actual prescriptions now are probably pretty low. Um, but even if you look at your lab kit, the amber liquid bottles on the back side of them will have the apothecary symbol for ounce on there. So that is something that you can visually see. So when you get that from your pharmacy, that's also on there. All right, let's do example 6.3.
3.
Okay, example 6.3. We have 3 fluid dram equals how many teaspoons? So if we go to our conversion sheet, looking here, we have 1 teaspoon equals 5 ml, which equals 1 dram. So we can pull anything out of this conversion factor, any two things out because they're all equal. So we're gonna take out 1 teaspoon equals 1 dram. And we have 3 drams here. How many teaspoons? So we would do 1x, which is just x, and then 1 times 3, which is just 3. So our answer is x equals 3, and that makes sense because if we have 2 of the same numbers on this side, we have to have 2 of the same numbers on this side. And we do, so our answer is 3 teaspoons.
Example 6.4, we have 6 teaspoons is equal to how many fluid ounces? So remember that symbol there is the ounce symbol. So on our pharmacy conversion sheet, we want to find a conversion factor that goes from ounces to teaspoons. So we do have one right here. So 1 ounce is equal to 6 teaspoons. So we can just write our answer in, right? We know it's 1 ounce. But if we needed to figure that out, we would write out a conversion factor going 1 ounce is equal to 6 teaspoons. And then on the other side, we have teaspoons, so we'd plug that in here, and this would be our x. Now, in proportions, when you have the same information on one side as you do on the other, that means it's equal to each other. So the answer without even having to do the math would be 1 because it's going to be, remember, these are equal to each other. So it's going to be the same. And if we did the math like normal, we would get that answer. Most conversions from metric to household, such as milliliters to teaspoons or ounces, are volume conversions, although length from inches to centimeters is sometimes used in the medical field. Right, let's do example 6.5. Example 6.5, we're going from 60 ml to how many ounces? So we're going to go to our conversion sheet and find a conversion factor that goes from milliliters to ounces. And highlighted down here, I have 1 ounce is equal to 30 ml. So I'm going to put that on one side of the proportion. Then, of course, on the other side of the proportion, we need to have the same units. So I'm going to just write those down now. We know that we're looking for ounces, and we have 60 ml. So if you think about this in a practical way, if you know that 1 ounce is 30 ml, then 2 ounces has got to be 60 ml, right? So eventually start thinking of things in that sense and kind of using numbers in your head to make those connections without having to do a math problem. So I'll still do it here. So 30x is equal to 1 times 60. And we know 1 times 60 is 60. So I'm just going to rewrite it. We want to get x alone. And if we take out our calculator and do that math, if we didn't know it, 60 divided by 30, we would get 2 ounces. Example 6.6, we're going from 4 inches to centimeters. So of course, we're going to go to our handy sheet and look for a conversion factor between inches and centimeters, which under miscellaneous conversions we have. So 1 inch is equal to 2.54 centimeters. So I'm going to write that down on one side of the proportion. And then on my other side, I know I need to have the same units across. And I have 4 inches in my problem, and I'm looking for centimeters. So we have 1 times x, which has just x, so I'm not going to write out the 1. And 4 times 2.54. Which gives me 10.16 centimeters. Which makes sense if we look at our number. If 1 inch is equal to 2.54 centimeters, sounds right that 4 inches would be equal to 10.16. The metric system uses grams, liters, and meters, whereas the apothecary system uses grains, minimums, drams, and ounces. The following important conversions to remember are approximations as stated earlier in the chapter. See those. An interesting way to think about the strengths of medication based on the conversion of 1 grain equals 60 milligrams is to think of a clock. There are 60 minutes in 1 hour, just as there are 60 milligrams in 1 grain. Therefore, if you think of 1/4 of an hour as being 15 minutes, 1/4 grain is 15 milligrams. Likewise, if you think of a half hour as being 30 minutes, 1/2 grain is equal to 30 milligrams. And if you think of 3/4 of an hour as being 45 minutes, 3/4 grains is 45 milligrams. All right, let's do example 6.7. Example 6.7, codeine 15 milligrams is equal to how many grains? So we're going to go to our conversion sheet and see if we have a conversion factor from milligrams to grains. And we do down here. So 1 grain is equal to 60 milligrams or 65 milligrams. For everything in this book, besides when we do calculations with aspirin and acetaminophen, we're going to use the 1 grain is equal to 60 milligrams. So I'm going to plug that into one side of a proportion. And we know on the other side we need to have grains and then we need to have milligrams. We have our 15 milligrams for this side and we know we're looking for grains. And just one little simple note I want to show you is see how we have grain written before the blank. Remember the apothecary system answers are the only system where we put the symbol or the abbreviation before we put the number. So this would be 60x is equal to 1 times 15. So we should know that 1 times 15 is 15. And we'll just rewrite our problem. So we have 60x is equal to 15. We want to get x alone. So we're going to cross or divide each side by 60. That crosses off and just leaves x. And now we have 15 over 60. So of course we can't leave it like that, our answer like that. So let's just plug in the 15 divided by 60 in our calculator. And that gives us 0.25. But remember, this is the apothecary system, so we can't use decimals. So we would normally need to turn that into or leave that as a fraction and reduce, right? But we should know that, 0.5 is 1/2, then 0.25 is going to be 1/4. So our answer should be 1/4. So 1/4 grain. Example 6.8, we have nitroglycerin sublingual 1 over 100 grain, and we need to figure out how many milligrams that is. So remember, we've already used our conversion factor of 1 grain is equal to 60 milligrams. Now, the book shows a different way of working this out. I like to work with decimals. They're a lot easier to do math with. So you'll see me converting back and forth between the two. But for this, let's turn this into a decimal, and that is going to make our problem over here a lot easier. So I'm going to get out my calculator and I'm going to do 1 divided by 100, which gives me 0.0. So I'm going to plug that 0.01 into here. Because remember, we had 1 over 100 grain, and now we've converted it into a decimal. We just need to find out how many milligrams. So we can do the math here, and we get 1 times x, which is x, and then 60 times 0.01. And that gives us 0.6 milligrams. And we are working with the metric system here. So we can leave it in decimal form. Conversions between measurement systems are approximations, and some will vary depending on the conversion factor used. The metric system is the most accurate method of measurement and therefore is used exclusively when compounding prescriptions and preparing intravenous medications. Conversions within and between measurement systems may be accomplished using either a ratio and proportion or DA. Once you learn the basic equivalencies listed in table 6.3, you should be able to accomplish any conversion needed in the pharmacy setting. So I do recommend when doing your problems for this assignment that you have your conversion sheet handy. Keeping in mind that you won't have that when doing the PTCB exam, but I have highlighted important conversion factors that you should make a nice comfy spot for in your brain because you're going to need to know them forever.